of this concept. Thou shalt understand. If you don't understand this, it won't make any sense ever. That is this picture right here. All right. What is that?
Cell.
It is a cell. What cell?
Body cells.
Whose body?
Mine.
Yes, it is. Good job. That's a body cell out of his body. All right. Which part of his body is that cell from?
Everywhere.
Anywhere and everywhere. This is just some body cell. It could be your head, your rear. I don't care. That's a cell in your body. What are those things I underlined in black up there? What are those? Yeah, well, yes, they're proteins. Yes, got that. They're MHC proteins. But in English, what are those? Okay, so I heard antigens. That's true. I heard receptors. That's true.
Compatibility.
I heard compatibility. That's true. But what are they for? Why would your cell have those?
Recognition that they're yours.
Very good answer. Recognition that they're yours. Okay. Silly analogy. When I go out in the parking lot, how do I know that's my crummy curl in the corner?
You press the button.
No, I don't have a button. That's it, man. What do you have a button? I'm a teacher. I'm not even with a button.
You recognize all the scratches.
Very good. All right, guys. Mine's the one with the hood peeling off the paint. It's got the broken fender. It's got the fog light with the deer mark. Okay. But I look at the outside of my car to notice it's mine. Your body does the same thing with your cells. You have to know that's yours. You have to identify or mark your cells so you know that's your body. Right? So that's an important concept that your body knows it's you. So watch your eyes. We're going to start writing down what that MHC protein up there is doing regarding that. So let's put that over here. So MHC protein. Okay, that has several names. Some people call it a marker, MHC marker, tag, stamp. It's actually formally an antigen, is the formula. It's an MHC antigen. But all those are meaning the same thing. All right? What they all mean is this word here. Self. What does self mean?
You.
Me. So every cell in your body is stamped or tagged that it's yours. And we call that the MHC protein. So in Dan's cell, every cell would look like that, with that shape marking it as his own. Does that make sense? That's self-marker, or self-recognition. So I'm going to show you something different. Behold, on the right of the screen. What is that? Oh, do you have a question?
So is everyone's completely unique to themselves?
Unless you have an
DNA?
identical twin, everyone's is unique. They're genetically components. So, in theory, no two people have the same MHCs. We'd have to test that by getting you transfusions and watching you die, but that's kind of hard to do.
Wait, different parts of your body.
No, all body parts have the same, but different people's bodies would have different MHCs. So look at that thing. What is that?
Foreign microbes.
Indeed it is. Pathogen, germ, disease. Look at its antigens or markers or tags.
Red balls.
Red balls, yes. Compare them to mine. Compare them to Dan's, right? Are these the same?
Yes. No. Well, they could fit.
No, are they the same?
Similar.
They're not the same. They look different.
Yeah.
Okay? So, let's go over here.
They look like they could fit.
They look pretty simple.
So the
Trick
pathogen.
question.
The pathogen, it has a different looking MHC. It has a different shaped antigen. So what do you call it if you don't look like self? What are you? You're non-self.
Foreign.
Foreign is another way to say it, but fancy talk, non-self. So the non-self antigen, the non-self tag, means I'm not me. So your immune system has to learn what is you and what is someone else to do its job. Because I have to kill that thing on the right and not kill the thing on the left. You hope not to kill your own guys. Yes?
How does that relate to like blood transfusions and like transplants? And
That's why the transfusion thing doesn't work with everybody, right? So your immune system learns that if you're B, that A is not you. B is me, A is not, and kills it. So the blood typing transfusion learns because the immune system realizes the A's and B's are self or not self, and attacks those. It's the same logic as what we're going to do today. It attacks a foreign type. Okay. So the concept of the immune system is you have to recognize self from non-self. You okay? Now we're going to hit you with the real hard jump in logic. The bottom picture. Take a look at this picture here and tell me what you see happening.
It learned it.
Well, yes, it's being processed. Got that?
It's now got the memory.
Look on the left-hand side of the picture. What's happening on the left-hand side of that picture?
Phagocytosis.
Right, so the virus, the pathogen is entering the cell. Phagocytosis, I'm eating it, pick a word. Okay, so the bad thing, the pathogen, the non-self entity is entering my body. Explain that. And silence
It
falls.
learned it.
Immunity.
Close. So if you look at what happened, this cell put the non-self antigen on top of the self antigen, right? It mixed the two. So that cell is no longer you, is it? That cell is now what? Not you, right? Because that's not me anymore. That's somebody else. So what do you think the immune system thinks of that cell if it's not you?
Bad.
Bad. And that's going to start the immune response to kill that because it's no longer you, it's someone else. Right? So what's going to happen in my immune system is I have to then take the bad thing and somehow make it so my body knows it's in there and present it to the immune system.
This is how vaccines work?
Vaccines work the same way. We'll go through them a little later. So do you get an idea of self and non-self? Okay, so now we're going to walk through the steps for the B's and T cells. So clear about 2 pages.
Is there an order to what's happening right there? Like,
Yes.
is it- what happened first? First
This.
it went in?
And then this came out.
and
So
that-
that cell gets
Oh,
killed.
that's
It
how-
will.
Okay.
So here you have 20 steps you have to write